is 42, and then 42, 7 times 6 is 42, 42 divided by 7 is 6, and 42 divided by 6 is 7. Back to the thought. These two times themselves have to give you that top. These two times themselves have to give you the top. But what happens when you stick 0 into this category thing here? Okay, let's say you have 0 times 8 is 0. Okay, and you use the same philosophy over here, correct? If you put a 8 on the top and put a 0 on the bottom, you need to come up with some number, just like we did down here. 0 times what number would give you 8? And if you know anything about your multiplication tables, it doesn't exist, because 0 times anything always gives you 0. So you are never allowed to divide by 0 because it just won't give you the answer you want, because it's the opposite of multiplication. The only time really it ends up actually working is if you had a 0 on the top. And 0 divided by 0, what would be the answer to that? No, not necessarily 0. Yeah, you could have 0, you could have 1, you could have 8, you could have 12, you could have anything here. This is kind of like infinity, because you can put any number there, 0 times 0. But what we're looking at today is this: when you talk about algebra and you have letters on the bottom, if you have 36 over x, okay, when you talk about that phrase, you have to do what we say is called state the excluded values. Okay. Which means this: when you see a phrase like this, you have to tell people that never, ever, ever can x be 0 on this. Because if you put a 0 on the bottom, it doesn't work. You put a 0 there, you're dividing by 0, which, as you look at, is one of the top 10 commandments, the top 10 commandments of math, that you can't divide by 0. Or if you had something that looked like this: 15 over x minus 3. What is the excluded value that x cannot be there? You have to think a little bit more than this, because x really could be 0 there. Because 0 minus 3 is negative 3. You get a negative 3 on the bottom. But what can't x be, Jaden? What number, when you subtract 3 from it, would give you a 0 on the bottom? 3. In this little phrase there, slash equation, x can't be 3, because if you take 3 minus 3, you get 0, and that's what you can't have. Or if you had this, 75 over xy, what would be the excluded values? The excluded values, things that can't happen, would be what? Jason?
Like positive 1 and negative 1.
I could put a positive 1 and a negative 1 in there, because that would give me negative 1. X times y is negative 1. I could have that. What can't x and y be? Riley?
Neither one of them can be 0.
Yeah, x cannot be 0, and y cannot be 0. Why? Because if you get either one of them to be 0, you get a 0 on the bottom. Let's look at one right out of the book. How about this one? Y plus 3 over 2y minus 8. Y plus 3 over 2y minus 8. What is the excluded value that y could not be? By the way, we put it as y can't be. And how would I figure it out? Maddie Marco seems to have all the answers. Yes, Maddie? What can't y be? Nothing? Isabel? Well, let's try. If I put negative 3 in for y, negative 3 times 2 is a negative 6. Negative 6 minus 8 is a negative 14. Yeah, I could have a negative 14 on the bottom. Keith? Huh? 4. 2 times 4 is 8, and 8 minus 8 gives you 0, so y can't be 4. Because you can't get the 0 on the bottom of the thing there. Is that what you got, Drew? No? Yes, no? Does that make sense? How about this one? I'm gonna just pick a random one. What about in this case? 7t over 3m minus 2. What can m not be? I like the quizzical look stuff. What can m not be? I am taking answers. Somebody going once, going 3 times. M cannot be come on, Fisher. Give me something to work with here. I like how all you try to do this mentally. How would you think of your mathematical careers, people? Think, how could I set all of this up? What am I looking for? I don't want this to be what? 0, right? So write yourself an equation. When will 3m minus 2 equal 0? Because that's what it can't be. How do you solve that equation? Just like any other equation. Add 2, divide by 3, divide by 3. What can't m be? M cannot be 2/3. Isn't it amazing how you can use your mathematical abilities to solve stuff like that? Was that what you were thinking, Elijah, and just didn't want to say it?
Yeah.
How about one more, right out of the book, 'cause I can tell. Oh, here's one. 16 over x squared minus 4. What cannot x be? Here, let me change that. Let's do x squared minus 3. What cannot x be? Elijah, did you come up with that one?
Almost.
Elijah?
1 and 1/2.
No. It's not a real, it's not a rational number. Square root of 3. So you'd say to yourself, when will x squared minus 3 be equal to 0? You add 3, you have now x squared equals 3, you take the square root of both sides, this gives you x. X cannot be the square root of 3. Actually, x can't be plus or minus the square root of 3, but yeah, that'll be what it is. But yes, that's it. Which isn't 3 and 1.5, which is I think what you were thinking it was. But is that what you were thinking? Square root of 3 is 1.5. No, it's not going to happen. Perfect. That probably, ladies and gentlemen, should end up getting you home.